please,
Yeah.
please set the slide first.
Yes. Okay. Are
Right,
you
Chandras,
able to see my screen?
yeah, we can see your screen, Chandras. Let's get started with closing session from Tapas and Chandras that explains the complete end-to-end 4G and 5G call flows, testing with the real equipment, and then we will move into the survey and close the session by learning about the spectrum and wrap up this whole thing. Let's get started, Chandras. Floor to you. Please go ahead.
Yes. Thank you. Thank you, Kader. Tapas, can you start?
Yeah. Sure. Thanks, Kader, for the opportunity to talk on the 4G and 5G demo. So basically, this is the architecture of the 4G, the OSS network diagram that we are using. So if you can see, we have Magma orchestrator in the private cloud, whereas we have the billing platform on the public cloud. And with the help of the API, both are integrated, and we have the 4G core. In terms of access gateway, that is the name, and which has two interfaces. One interface is the one IP, and the other interface is the LAN IP. You can see that the access gateway is connected to the fiber optics in the left hand side, and the right hand side, the ENB is connected to the access gateway, and the private, LTs, the EUEs are, connected to the ENB. So this is basically the high-end architecture of the 4G. Can we go to the next slide, please,
Yes.
Mickey? Okay, so these are the components basically that we are going to use during the demo. So if you can see that the Magma basically laying over both the cloud and the service provider edge, whereas in the service provider edge we do have the Magma access gateway. Basically, we do have a Magma hardware physical access gateway box inside our lab, which during the demo we are going to show that as well. And we have the Magma orchestrator and the NMS dashboard, which is running inside a private cloud, and also that private cloud is hosted inside our lab. So we are going to demonstrate that as well. And the infrastructure management, for overall infrastructure management, we are using Kubernetes, OpenStack, and Ansible. And for the cloud infrastructure, right? So we do have Docker, OVS, Swiss, and KVM. All these components are being used. And we also have the Bicel ENB in our lab, and we are using UE Samsung M21 as a UE, right? So these are the components that we are going to use for the different user aids, for the user aids, the UG, and service provider aids for the access gateway and ENB. So can we go directly to the video, Chandras?
Yes. Shall I start?
Sure.
So this is our 4G 5G converse 4G 5G connectivity lab, which is located in our Hyderabad Web Labs office. As you see, it is our connectivity lab. These are all our servers. This is Dell server rack, where all the Dell servers are put it. And these are all our assembled servers. It is a backside of our Dell servers.
Basically, these Dell servers are basically used to host our private cloud, which is the OpenStack private cloud.
It is the backside of our and it is a backside of our assembled servers. Assembled servers and Dell servers both are connected through the switch. These are the switch. And this is our Magma hardware AGW box, which is connected through the switch also. And this is our eNode B, which is used for 4G private network. It is also connected through the switch. Both Magma AGW and our eNode B are connected through the switch. It is our SIM card reader, which we use for burning a SIM card. And after burning a SIM card, we will use that SIM card into our testing purpose in a UE. These are all our dummy SIM cards, which will be used for the testing purpose. So now I take a one SIM card. First of all, insert the SIM card burner into our system. Now insert a one SIM card. So first, after insert a SIM card, the LED will be turned into red and green. After few seconds, it will be constant red. It means our SIM card is inserted successfully. Then we will use a one software to burn a SIM card. In this software, we will use K value, OPC value, and selected PLMN. This is our UE. It is a physically a Samsung M21, which will be used for a testing purpose. So now we will now we will activate a one SIM card, and after activating we will use and see the billing activity. So for adding a SIM card, first we will go to the NMS dashboard page. Uh, yeah, in subscriber, as you see, there is only 4 subscribers are added.
Sir, anybody
So
can
for
access this wave lab, sir.
sorry,
Anybody can
hello.
access this wave lab, or is there is any specification to access this wave lab online sort of stuff?
So this is
No, it is
anyone can access. Basically, this is publicly available. If you want to go and try, you can contact us. We can create a tenant for you.
Yeah, Pankaj, can you introduce yourself, Pankaj, before asking the question? Just to
Yes, sir. I am actually Pankaj Chawla. I'm a researcher at IIT Jammu, sir. I'm working on 5G and 6G infrastructure.
nice, nice. Yeah, why don't we talk offline? I'll connect you to the engineering team. Maybe we can do some collaboration between your organization and the labs that we have set up through this program. Okay,
Okay.
right?
Okay. Actually, basically, I'm a PhD scholar there. So if you see, give me specification, I can talk to anybody, like what sort of labs you have, sort of stuff.
Yeah, yeah. So let's talk offline, right? The collaboration, and you can always reach out to us. I'll actually send you this. You can look at the chat, right? So you can always reach out to that, and also you can reach out to us through info at decoding 5G. I'll send you the stuff. Okay.
Okay. Okay, sir. Okay.
Let's move forward with the demo.
Okay, so for activation of one SIM card, first of all, we will go to the admin page. Okay, so now I am logging into the admin page. As you see, we can go to SIM card. So as you see, there is only a few SIM cards. So first of all, we will add a one SIM card and assign to the dealer. So now I am adding a one new SIM card. IMC number, auth value, OPC, and price. After see, as you see, the SIM card is successfully added here. Now I assign this SIM card to a dealer. Sorry, to a franchisee. Now all these will be selected manually. Now we will log in into the franchisee account. Sorry. Same as it is. The admin is successful the SIM card to a dealer. We can select manually here. SIM card is successfully assigned to our dealer. Now dealer will be assigned the SIM card to a retailer. So first dealer will be go and check the SIM card will become into a dealer criteria or not. So as you see, key for dealer SIM card is successfully here. Now we will assign this SIM card to a retailer. And retailer will be assigned this SIM card to a customer. Now we will log in into the POCF where we will do the activation. So first of all, we will go to the stock page and check our SIM card will be available for customer or not. As you see, our SIM card is successfully available here. Now we will do a digital KYC for activating for activation of SIM card. We can use any of our international and national IDs for activation purpose. First, we will give the document number, customer name, date of birth, nationality, alternate number, and mail ID, and everything we will assign here. Now we will select a SIM card and we will select a package, data package. Now we will check all the information and proceed for the activation. So as you see, our SIM card is successfully activated. Now we will go to the NMS page and refresh this page. After refreshing, our subscriber we can be see here. As you see, subscriber is successfully added into the NMS page. Now this is our customer web page where we can check our how much data we have used and how much data is left. So here you see at the time of activation, I allocated a 1 GB data to a user. So now 1 GB data is successfully assigned to this customer. And now we will capture all the logs through the AGW. So I open a two terminals. In one terminal, I will take a TCP dump. In second terminal, I will take a MME log.
Basically, now we are going to establish the call flow. And to check the logs, we are just, accessing the access gateway.
As you see, our UE right now, our UE is connected through a Wi-Fi. So now we will go to the network settings. We will select a network, search a network, and then we will, as you see, we have selected CMCC. CMCC, our 4G private networks. So first of all, we will select a network. As you see, our UE is successfully attached with a network 5207. And as you see, 4G private network is there. Now we will use a data and check the billing activity is happening or not. As you see, services is active, current users is 0, and daily average is also 0. And in our customer web page, there is 1 GB data is left. Now we can go through the YouTube or Play Store also. So now I am starting a downloading through the Play Store. As you see, current users and daily average is 0. Now I have refreshed this page. As you see, now I am using 1.68 MB data. It is also reflected in Wavelab's customer web page. It is synchronization time is around 10 to 20 milliseconds. Yeah, as you see, previously it is 1 GB data. Now it is 0.998 MB data is left. Again, we refresh the NMS dashboard page. It is 479.15 MB data current uses, and then we will refresh the Weblabs customer web page. So now you can see 0.5 to 5 around 500 MB data is left. So now our billing is successfully happening. Thank you.
So yes, here with here, we are just completed the 4G call flow. Now,
Yes.
can we start with the 5G call flow?
Yeah. Nilima, can you please share your screen and
Yes, Chandresh.
Yeah.
Hi everyone. Now we are going to see the 5G call flow with the Bicel UE device. I'm trying to start the TCP dump here. Enabling the MME and syslogs before starting the call. from the device. And this is T-Shark, which will give the live captures of the packets, NAS messages that we are trying to capture with the T-Shark. Now my UV device is in aeroplane mode. By turning off the aeroplane mode, I will get connected to the 5G network, where we can see that PDO establishment is successful here with setup response message. I'm trying to ping with my IPF, Magic IPF inbuilt IPF support. I'm trying to ping the network host, or we can say that server from the UV device, and we can see that ping data is successful. In the previous sessions, we had gone through the detailed packet structures and like each and every message structures, and also here I'm not going into that details. Yeah, with this, I'm able to show that, I mean, we are able to make a successful 5G call and access the sessions for exchanging some basic data. That's what I mean to demonstrate here. Thank you.
So Kader, we are done with the 4G and 5G call flow
Nice.
demo. So basically, back to you.
Thank you. Thank you very much, guys. That's really good. Now let's do a few things. Let me share my screen here. I think, wait. Before we get into the understanding about the spectrum, let's, while we are going through, right, I like every one of us here, 20 people, please click this survey link and fill it up, please. Even I'm also going to do the same thing right now. Let me share my screen and then I will show you. Is it? Yeah, just click this survey link and open it in any browser. Yeah, I'm just going to do it along with you, right? So I'm just doing my first name. Please go ahead. You all please do this. Like to have it completed. It just takes 3 minutes, and then we will get started with the second section of this program. Feel free to provide personal address if you don't want to share your company's address. If you don't prefer to say your racialized status, you can always say prefer not to say. So what we will also do is those who had attended the session above 60% attendance, we will also send you guys, it will take probably a month or so, but we will send you a certification of attendance for sure, right? So just make sure you provide your right names, so that the certificate is created. All right. So please let me know. Let me check here if you guys have submitted it. So I've seen so far 3 responses. I would really appreciate it. If you guys are not in the computer, can you please copy the link and keep it with you so you can finish this survey? If survey is not done, we will also reach out by email to ask you guys to do the survey. But I would prefer that you do it now while I am actually continuing with the session to close this program, that long 12 weeks program today. Okay. All right, let's get started. So what I would like to really do is jump straight into what we have achieved so far, and then close with the spectrum, right? That we wanted to learn, at least the basics of the spectrum, so that we can get started on, at least we have an end-to-end knowledge, and what we wanted to really achieve, we have been able to successfully achieve, right? So that's the conclusion that we wanted to really get to. So if you actually look at it, the way that we started, why we actually started doing this is because there's number of different technologies, thought leadership around these technologies, how it will evolve in future is under discussion, which requires a strong network layer, right? It doesn't mean that network layer is the only thing, but it requires a strong network layer along with strong infrastructure layer, along with strong applications to enable the convergence of physical, digital, and human world. And in order for us to really do that, like I mentioned, every layer is important, but the network layer is critical to make it happen. If the network layer does not have enough bandwidth, does not support low latency, high capacity related features, the use cases built around those features will not become reality, right? So that's the key reason. And what we wanted to really achieve in this program is, by going through this 12 sessions, we wanted to build our expertise and we wanted to understand an end-to-end how different things work, right? That was the goal. And we chose a path of using the open source to enable the knowledge as well as understand the end-to-end flow. And we focused on 2 things. We structured our programs in order to build our expertise and also understand an end-to-end solution. We structured our program in 2 parts. Every program had understanding on end-to-end picture theoretically, and then the second section had understanding the whole thing practically. That is how we kind of structured this whole program. And in fact, we were going through a number of different sessions and going through a number of different demos, both theoretically and practically. And I strongly believe that as of today, towards the end of the program, we have at least put a seed to help you guys to grow and become beneficial, right? So that's the way that I look at it. And from all the agendas that we planned for, we have been able to successfully complete it, including showing the end-to-end solution demo with the real equipment for 4G and 5G today. Thanks a lot for all the speakers and all the contribution from every one of you. And when it comes to the end-to-end knowledge point of view, what we wanted to really understand, in addition to seeing all the practical things, we wanted to understand the big picture. So we started with understanding what is wireline networks, right? The basics of wireline networks, the basics of wireless networks. What are all the standards and open sources that are out there? There are so many, but we try to understand few things. And then we also try to understand what are all the different adjacent technologies is driving 5G and the future 6G that requires an automated environment and 10x time, 100x time more numeric data with respect to the throughput to latency support is required for future applications and so on, right? So we kind of looked at that. And then the last one that we wanted to kind of understand is at least the basic of spectrum, right? So we want to kind of wrap this. So we are really thorough from the point of view of end-to-end picture. So we started with understanding the wireline networks. We started with very basic stuff. I'm just running through this so you get the kind of trailer of what all we discussed, what all we learned, right? It's not a, from my point of view, it's a great achievement. We started with understanding the wireless network, understanding very basic in olden days what happened, how things started evolving from PSTN network to the data network to the voice over IP network to the transport network. and how the multiple different types of networks started converging with the inception of IMS, right? And how the architectures changed is what we learned in the wireline networks. And then we jumped into wireless networks. We looked at the evolution of wireless networks from 1G to 5G and how business-driven communications turned into a business-critical communications and mission-critical communications that we are able to offer through 5G. And not only that, we also looked at how it can enable different industrial era and different technologies that are out there, how all these different technologies come together to really solve the customer problems is something that we really try to understand, and how all those customer problem applications that you build can be supported through 5G because of the way features that it supports, like enhanced mobile broadband, URLLC, and MTC features that it supports, and the use cases, example use cases that each of these different 5G based use cases can support the practical customer based use cases. We looked at that and the evolution from 5G to 6G. Why is it happening? Why do we need? Because we need to stretch the KPIs to offer bigger use cases that requires bigger throughput, bigger bandwidth. And there's a lot of work is happening on 5G evolution towards the 6G. Yes, of course, it's years away, but as a thought leaders, if you want to be really successful, there's two ways to look at the world, right? One way to look at the world is tactically do whatever is required now to benefit from it, and then strategically involve yourself and invest today to be ready for the future, right? So these are the two things that you as an individual always have to consider and always have to balance, right? So it's not only on your personal life, but also on your professional life. You have to learn today what is required for you to survive and invest time to learn something so you can be ready for the future. That is what is all about continuous learning. That is what is all about future skills and innovation. That is what is all about you becoming a workforce of future, right? So the goal of Testoper community is really to help you to become a continuous learner so you can be future workforce, you can be a workforce of future, in other words. Okay, so it's all kind of connected to this, right? And then we kind of looked at the basics of 5G, an end-to-end picture of different components that cellular network has, and how the network evolved from 2G to 3G to 4G to 5G. And in 5G, what are all the different types of architectures? We looked at it. And then we also kind of saw how the 5G evolved from 4G. Okay. And we got into a ORAN. This is a new initiative that's happening, not a new initiative. It's not picked up really well, but it's a great initiative. The idea is to really, come out of vendor dependency and ability to, be a non-vendor dependent open source and deploy a disaggregated or aggregated, right? Radio, depending upon the use cases that you wanted to solve, right? So we talked about ORAN. We talked about different components of ORAN and different splits of ORAN and some of the features, key features that are related to the ORAN. Then after understanding the ORAN, we got into the transport network, try to understand the basics of transport network slicing. Then we understood the private network, what's the difference between the public network and the private network. So that kind of wrapped up an understanding of very basics of wireless networks, evolution from 1G network to 5G network. Then we got into standards and open source. We started looking at what is 3GPP standard, which is very basic, how you can go and get access to and understand different features that's happening in 3GPP that is getting developed in 3GPP organization. And we picked a couple of, like this, there are a number of organizations, right? Domain specific organization, but we picked number of domain specific organization and try to understand how these organizations are helping to evolve a specific domain, right? So this ACIA basically is an industrial 5G, and we looked at what kind of work that they are doing it. Then we looked at TIP as another organization. They're not standard bodies, but they're another organization who basically provide input back to the standard bodies and so on, right? All these other organizations does that. So we looked at that and what work that they are doing. And we looked at what are all the different open source activities are happening, not only from the network layer point of view, but also we studied and understood a different open source that is available that can make up all the different layers of the open source, all the different layers of the 5G super blueprint. And we talked about Linux Foundation networking and their great work in pulling together the 5G blueprint, how it actually helps to build the prototype, build the use cases that you can test it in the lab and eventually take it to the production. So we went through, we understood that completely. And then we also understood we kind of looked at how Magma as an open source compared to all these different standards and the test plans that are available in TIP. So that kind of brought us to the understanding of the end-to-end picture of the standard bodies. Then what we got into is we tried to understand the adjacent technologies, not only looking at 5G, but we were trying to look at what is cloud, right? And how that evolved. What is SDN? How that evolved? What is NFV? What's the difference between cloud, SDN and NFV? How all these different things that come together to solve different use cases. And we got a little bit depth into the NFV, and we tried to understand different templates that you use in NFV. One is to onboard, another one is to actually, dynamically that gets updated, and try to map that to heap template, and what other templates that are out there in Kubernetes, OpenStacks, and so on, right? Then we try to understand, okay, what is network function? What is network service? How the actual end-to-end network service is built in this modern infrastructure and platform. Then we try to understand what's the difference between different types of cloud, right? Edge, regional, national, and in edge, HC contribution towards the architecture of multi-access edge computing is something that we looked at. Then we got into, again, depth of all the different open source component. We went through every open source component to understand how all these different things comes together to build an end-to-end network. This is what I was talking about, a solutioning, right? We started with vertical, understanding only 5G, and then we try to expand that into understanding the big end-to-end picture, right? Both expertise and solutioning. So then we looked at, again, we kind of refreshed it. Then we started looking at adjacent technologies. There are so many other technologies were there, but we started looking at how AI can contribute. What is Web 3.0? How it is democratizing and decentralizing the networks. And we looked at some example, we looked at metaverse, and we looked at some differences between centralized and decentralized network, how all these decentralized networks are evolving and becoming a global network than a network that is available in different countries provided by different operators, right? So how is this happening? We looked at it. And the most important thing, we ended this whole discussion with understanding the blockchain, right? How blockchain is actually helping to build a decentralized economy, decentralized, distributed, democratized business model, right? So that kind of brought us to the end of understanding the wireless, wireline. Then you got into understanding that, yes, the standard bodies, and understanding the end-to-end different technologies, how all these things come together. So I'll pause here. If you have any questions or anything, please feel free to ask. And then we will jump into the spectrum. I'll give you some very basic things, right, to kind of wrap that up, so that you understand the basics. It's very important, right? Without this, you won't complete this whole session. So I'll get into this and I'll explain. I'll pause for a minute for any questions. I would need another 10 to 12 minutes. I think we are on time to finish the spectrum. So I'll pause for any minutes for any question, a minute for a question. If not, I will continue with the flow. Okay, you guys can hear me, right?
Yeah. No question.
All right, perfect. Let's jump into spectrum. Okay. So now you understood the wireless technologies and all those kind of things, but you have a phone that connects to the radio. No wire is there from your phone to the radio. And in order for you to connect whatever you speak, whatever you browse, whatever you communicate through the phone, it has to reach it to the other party, right? So in the air, you actually are transmitting by magic, right? And that whatever you're trying to transmit through the air is regulated, right? And you can't just transmit in any frequency, okay? It is regulated, and that's nothing but is actually a spectrum, right? So if you look at it, what spectrum is, you can think of it's an invisible radio frequency, right? Where you're actually transferring your data from your phone to the radio. That is what it is, okay? Now the spectrum is actually divided into multiple bands, okay? Remember these words, right? You have a spectrum. I wrote it down here so that it could be easy for you to read it offline when you're watching the video or whatnot. But I'll try to, explain only that are key points, right? So you have the spectrum is always divided into multiple frequency bands. Okay, and that frequency bands are always auctioned when the frequency band is auctioned, where the Rogers, Telus in India, Airtel in US, AT&T, when they actually buy the spectrum, what they are actually buying is they're actually buying a frequency band. Not only that, they're actually buying a block within the frequency band. Okay, I will explain what are all these different types of frequency bands and all is available. I'll explain that in the subsequent slide. But what you need to understand from the basics is there is a phone that connects to the radio, and in between in the air, that's nothing but your spectrum. Whatever you're communicating from your phone to your radio is through frequency, right? Radio waves, and the radio waves is regulated, through frequency bands. And there is a word called spectrum, there is a frequency band, and there's a block. These are all the three things that you need to actually remember, right, at a very basic level. So as an example, right, when you are, let's say, for example, I am Rogers and I wanted to provide a service and I wanted to buy some frequency band. Don't worry about which service I wanted to provide, right? Just think about, in order for me to provide the service, I need some frequency band that I can transmit my signal in the air. So first is you decide I wanted to buy 2100 frequency band, and in 2100 megahertz frequency band, I wanted to buy the 30 megahertz block. Then you go and put your money in the auction and you buy it. But now you buy it for obviously to deploy some use case, but leave that out. So that is how it is actually done, right? So you have a spectrum, you have a frequency band, then you have a block. Remember these three things, okay? I will explain with some practical things afterwards. Then what you have is there is something called as a paired band and unpaired band. This is also very important for you to understand, right? So what is a paired band? That's nothing but FDD. In FDD, what happens is, let's say you are trying to buy a 700 megahertz, and then within the 700 megahertz, that range, right, 700 to 800, whatever. So you get 718 to 748, right? 30 megahertz band, right? 18, 28, 38, 48. 30 megahertz, you use it for uplink. 30 megahertz, you use it for downlink. So you always have a dedicated frequency band to send the uplink data that you originate from your phone, like for example, when you're speaking, right? And the downlink data, your friend is speaking, right? So these two things happen in two different frequency bands, right? When you transmit and receive. So that is nothing but your paired band. If you wanted to deploy frequency division multiplexing, technology as a radio technology, right? Any operator, then they have to buy a band for uplink, they have to buy a band for downlink. But when they actually buy a band, it comes with both uplink and downlink. But this is an example, right? I've given here telco A wins one block, 5 megahertz of 700 megahertz band. It will mean the telco will assign, assuming something in between 723 to 728 for uplink, and then 778 to 783 for downlink. So this is another thing that you need to remember, paired band. Okay. So again, I repeat, these three words are critical, right? Spectrum, frequency band, block. Okay. These are the three things that you need to remember. And in the band, you have a paired band and unpaired band. Unpaired band is the TDD technology. So with the time slot, sometime you send uplink, sometime you send downlink. So you don't need to have a dedicated two blocks. Okay, so that is what is an unpaired band. Okay, these are all the four things that I wanted you to really remember. Okay, what is a frequency? What is a what is spectrum? What is a frequency band? And what is a block? And what is a paired band and unpaired band? Right, very basic. You need to remember this. I just put some example here in India, right? So 800 megahertz band was used by CDMA technology, by Geo, CDMA and LTE, right? The 900 to 1800 megahertz band was used by GSM for 2G, 3G, and so on, right? I just gave some examples so you kind of understand relating to what I was explaining you guys. So let's pick an example, right? 2300 megahertz to 2500 megahertz is used in India for LTE services as an example, right? So just to give you an understanding of those three definitions, right? Spectrum, frequency band, and block. Remember that, okay? Now I will really get into a little bit depth, a little bit extra in spectrum. So if you look at the whole spectrum, right, it's divided and it's given the name like this: VLF, very large frequency, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, and like that, right? So you have number of different names that is given for the spectrum. And in that name, you actually see here, right? 3 kilohertz to 30 kilohertz is in between these things is used for VLF. 30 kilohertz to 300 kilohertz is used for LF. 300 kilohertz to 3 megahertz is used for MF, and likewise, right? So increasing wavelength meaning the distance, right? The lower the frequency, the higher the distance that you can go. The higher the frequency, the lower the distance that you can go, right? This is important to understand, very basics of spectrum, okay? I have another slide that will explain you a little bit more on that. But what's more important for you to understand in this slide is that in the frequency is divided from 3 kilohertz to 300 gigahertz frequencies, bands are available, right, in the spectrum, right? Within these frequency bands, multiple blocks are assigned for different companies to provide different services. If a company buys a block within a frequency band between 3 kilohertz to 30 kilohertz, he can use that band, right, to provide maritime radio navigation services. It's quite obvious why the low frequency is provided to maritime, because the ocean is so big, right? You need a bigger coverage. So you need to provide a low frequency band. So you can cover the distance, but the throughput will be very low, right? So likewise, 30 to 300 kilohertz, some frequency band, if someone is owning frequency band / block, if someone is owning, they can provide maritime radio navigation, right? Then likewise, someone is here, they can provide radio. Someone is here, shortwave radio. Someone is here, they can provide television. Someone is here, they provide mobile phones, right? 300 megahertz to 3 gigahertz, you can see mobile phones, the real 2G, 3G, 4G and all comes into the picture. Then 3 gigahertz to 30 gigahertz, you have satellites. And then 30 gigahertz to 300 gigahertz, you have astronomy and future related stuff, right? This is how the spectrum is divided. And this is the very basic thing that you need to really understand, right? So now I go back to those three definitions, right? Spectrum, frequency bands, and within the frequency band, some block the company buys, they can provide all these different services within that. Very, very important and very basic to understand. So this is that slide that I was talking to you about. The lower the frequency that you have, the higher the coverage that you can cover. If the frequency is higher, the lower the cover area that you can cover. But if the frequency is higher, the throughput will be more, right? You can do speed more. So it's a compromise between the coverage and the data transfer capacity. Depending upon the use case, you will buy the frequency band / block from the government, so you can provide that particular service. Okay. Now this is this is just for the display purpose. So this is a frequency band defined by ITU, right? So you see here extremely low frequency, 3 to 30 kilohertz submarines. Now if you go down here, very high frequency, 30 to 300 megahertz, it's used for television and also used for mobile phones. Now very high frequency, and you also have multiple bands, right? What more important for you to understand is ITU defines like 12 bands, right? 8, 9, 2 times I've copied 8, 9, 10, 11, 12 bands. So all these 12 bands has certain frequency range, right? In other words, frequency bands. Within this frequency bands, company can buy some blocks so they can provide these different services. And you go and procure the frequency band depending upon you want more coverage or more speed or both. You need to come in between somewhere and you buy the right frequency from the government to provide that services. This is how the ITU defines the band, right? And IEEE also a little bit expands further, right? But it is still within what ITU is doing, right? So you can actually see here high frequency, very high frequency, long wave. So they also further split the frequency band within 0. That is 3 kilohertz to 300 gigahertz, right? You see here sometimes in satellite and all, you might hear Ku band, Ka band, K band. These are all the things that you hear during the satellite. Satellite is working in V band, Ku band and all, right? So that means that satellite is actually sending and receiving the traffic within 12 and 18 gigahertz. That's what it means. right? Between 12 and 18 gigahertz frequency band. Within that band, the company who's operating the satellite might have bought some blocks and they are sending and receiving the traffic. And the equipments that it is available can send and receive the traffic within 12 to 18 gigahertz, called as it is compliant to Ku-band. When you buy a phone, right, it says it supports 800/1100/ blah 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 band it supports, right? So you don't blindly go and buy the band, right? You actually go and understand that the phone that you're buying and the service that is provided by in your country actually has all those things, and then you buy. Okay. All right. So now you can also, another thing that you can understand is you can go to the Wikipedia, and sometimes some names are used, right, differently. So I kind of bring up here. Sometimes the LTE, right, band that is used, sometimes they are also called as band 1, band 2, band 3. They say, hey, you know what? This is an FDD and this is my band 1, band 2, band 3, right? So, you have to kind of look at it. There's sometimes for LTE itself, they kind of define something. The same thing for 5G, they use something called N1, N2. You might know that CBRS that is used in US, right? CBRSC here. A lot of people say band N48. Does your radio and phone support N48? That's what it means, right? If you have this N48, then it works in the CBRS band. If your phone doesn't support N48, it won't work in the CBRS band, right? In some countries, N71, some countries N34, right? So it, depending upon which technology that they are deploying, paired, unpaired, right? All those things that you have already learned, right? Those are the very basic words that you have to know. And then if you go to these links, it becomes very easy for you to kind of relate to everything. Okay. So now, just a quick recap, right? Spectrum, frequency bands, blocks, paired band, unpaired band. That's how the company buys it. Different types of spectrum has different types of frequency bands. Whatever the block you buy, depending upon you want to provide a maritime radio, you buy a block within the spectrum and you build your application to provide, right? And we talked about coverage and throughput. The higher the frequency, the speeder it is, the lower the frequency, the more coverage it is, right? Then we looked at how the ITU defines the band, IEEE defines the band, and LTE sometimes they refer LTE 5G, they refer N2, band 1, band 2, band 3, N1, N2, N3. So you need to know. They further split the different things specific for LTE and specific for 5G NR. You need to know that. Now, what's also important is that just to give you guys perspective, I kind of put in here, you can actually Google it, right? Canadian spectrum chart, right? Like that, whichever part of the country that you are in, you can actually do that, right? You would know. I just wanted to show this in a practical way for a minute. So if I take this as an example, let's say 50, okay? So you see here all these things you learned already in this session: VLF, LF, MF, HF, VHF, UHF, SHF, and EHF, right? These are all the different things that you have learned. And you see here all these different coding. So all these different coding, it is too small here. Let me see if I can actually make it a little bit up big for you guys. If you see here all this color coding, you will see here aeronautical, broadcasting, land mobile, maritime, radio, right? Intersatellite, radio astronomy, all those things that you saw in this slide. Go back here, right? All these things that you saw in this slide, right? Every country within their location, within their area, geographical area, they allocate to people who are providing the services, all these different spectrum, they auction it and they provide, right? These are all the different things that you can actually see here now. Within VLF, there are a lot of things that are not allocated. Some are allocated for few activities, right? Mostly not allocated. Let's go down, right? The below one, ELF. So now you see the color code here. So the color code here is this. So it's actually fixed for now. And there is a dot here. So that, you can you understand, right? The purpose is not to explain, but I will see if I can pick some good example to explain. Okay, let's say middle, this one MF will be the good one. So here that you see here AM radio, like within this 300. So sorry, let me also show this. See, when you start with VLF, you start with 3 kilohertz, right? And then what you do is you end with here 30 kilohertz, right? So then here down, you start with 30 kilohertz and then you end with 300 kilohertz, right? And then the next one is medium frequency. You have here 300 kilohertz you start with and you end with 3 megahertz. So within this, let's look at example. So within that, okay, 300 from 535, some from 525 all the way to 1705 is being provided for AM radio. Right? You get an AM radio, no, in your country, right? So like in Canada, that is what is provided for AM radio. Now, if you go to the high frequency that starts from 3 megahertz and then ends in 30 megahertz, let's pick something here, right? Industrial, scientific, and medical reasons, they have allocated this band, right? 13.57, right? Just as an example. These are all 20-meter bands, right? So National Research Council has got some. Right? So now let's go to our mobile stuff, right? Which normally happens after 300 megahertz. These are all is for the satellite, right? UHF. You see here, satellite they have provided from 300 megahertz to 3 gigahertz. You can actually see satellite radio networks, personal communication service, advanced wireless service, mobile satellite services, right? So they have provided it. Now let's go down here. SHF, radar, satellite. See here, Ku band. You remember in that slide? So you have this Ku band here, domestic satellites. These are all is provided between that to 30 gigahertz. Now let's go down further. 30 gigahertz to 300 gigahertz. So here you would actually see, just checking if there is anything that I can actually show you guys. I don't know if I can actually search on this. And mobile. See here the blocks here. These blocks A here, A here, A here. These are all some of the blocks that are provided. See these blocks here, the color. You have to match that to that color, right? Or provided for mobile communications, right? So many blocks you can see here within this. These are all provided by the mobile communication by the government of Canada, and some part of it is bought by Rogers, some part of it is bought by TELUS, some part of it was bought by Bell and other service providers here to actually provide the services to mobile services to the end users, right? So that's the key thing that I wanted to share it with you. If you actually look at it here, mobile phones, you would actually get it somewhere between 3 megahertz to 3 gigahertz, right? So 300 megahertz to 3 gigahertz. That's where 800 megahertz, 900 megahertz, 2.1 megahertz, and some other things like here, right? Where is it? I want to show you here. So these 30 to 300 to 3000 gigahertz, right? This is where actually the mobile phones are actually used, right? So that's pretty much it is that I wanted. Okay, this is a good place to actually show. Just wondering where did it go? Yeah, okay, here. So you see here, right? So uplink and downlink. So see here 2100 megahertz. These are all the megahertz normally, right? Which is basically 300 megahertz to around 3500 4000 megahertz is normally used up to LTE. Now what's happening is above 6 gigahertz to 30 gigahertz, they are providing it for millimeter wave. That's something it can again be used for 5G, right? That you actually see here. This millimeter wave is different, right? But end of the day, I think that's what it is that I wanted to really communicate with you guys as a very basics for spectrum. So you have a picture of this. So, the thought process of this is what I wanted to really do you guys to understand is that when someone, end-to-end picture, right? It's not only about radio, putting it in the lab, but actually when you wanted to go and deploy in some customer, first thing that you need to ask is, hey, are you going to use, do you have a spectrum, right? If they don't have a spectrum, you can actually deploy 4G and 5G. But there is something called as an unlicensed spectrum. This is the last thing that I wanted to let you guys know. So there are a lot of government also allocates some unlicensed spectrum. Okay. So in the unlicensed spectrum, I've given some, LTE frequency band for US, Canada. In unlicensed spectrum, you can actually Google it. So you see Wi-Fi that we use at home, like 2.5 gigahertz and 5 gigahertz that it says, right? In your thing select, when you do a select Wi-Fi, your Wi-Fi network comes in 2.5 and 5 gigahertz, right? The more frequency, remember, it's faster, but the coverage will be less. If you're living in a big home, right, and if you have a 5 gigahertz, if you go a little bit far away, you will not get a good signal, right? But if you're closer to the router, the speed will be really fast. But if you choose 2.5 gigahertz, lower frequency, you can go a little bit farther in your home. If you have a big home, you still have a coverage, but the throughput will be low. It's the same concept, right? So 2.5 and 5 gigahertz is actually used for the Wi-Fi. Backhaul for Wi-Fi, nowadays people are providing 60 gigahertz, right? For backhaul Wi-Fi. So what does it mean? Practically is backhaul is unlicensed spectrum as well, right? So that they are providing. So a lot of implementations in 5G, what's happening nowadays is because the 5G spectrum is not available, in the front, what people are doing is they are putting a CPE. So the actual mobile phone connects to the CPE is all Wi-Fi, okay? And then the CPE has a SIM card, and that CPE connecting to the radio and other things, it tries to do it with the backhaul unlicensed, and then you basically do whatever, right? Signaling that you wanted to do. A lot of deployments are happening like that. On the core side, it's 5G or 4G. On the front side, it's actually a Wi-Fi, right? Because of the band not available, a lot of things are happening. When the band is available, they can change that to 4G and 5G directly. So anyways, so that's the big picture that I wanted to provide about the spectrum. And that brings to the end of our session, Decoding 5G.Zone. I will pause here. Guys, was it helpful? Are you able to understand the big picture?
Yes, Kader. Yeah.
Yes, Kader.
Perfect.
Yes, Kader.
Okay, so this is very critical, and I will try to see how I can share this slide with you all. I will create a PDF, and then I will probably, we should have your email addresses. Whoever fills the survey only will get the slides, right? So feel free to fill the survey, and then we will try to send out the slide to you so that you always keep this as a reference, right? That we went through from basics of wireline all the way to the spectrum, so that you have this big picture. Getting into details is easy part, right? It's like reading the book and doing it, right? It's over the period of time you will become expert. But what's more important is understanding this big picture that can allow you to become expert. Getting into the depth is the critical piece of this whole puzzle. All right, so we are 4 minutes outside of planned time, but I would like to sincerely thank every one of you for all your contribution towards this continuous learning session that we came together and we learned together in last 12 sessions. From my point of view, it's an awesome opportunity that we went through together and learned together. Kudos to everyone who attended and developed their skills. Kudos to everyone that helped others to develop their skills. This is what I call it as learn to learn and teach to learn. It's very important to understand, you guys to understand this. You can learn to learn, but if you become teach to learn, right? When you teach others to learn, you learn actually more, okay? Learn to learn, you forget things. But whatever you learn, try to take that and teach to others, you will never forget. Even that you will forget, but you have to continue teaching, right? So remember this, whoever contributed for both learn to learn and teach to learn, thank you very much. And you guys are Awesome, right? The last but not least, what we are trying to put together is, this is mostly for the people who are living in Canada, is we are putting together a program on October 28th. We are doing a 1 full day conference called Decoding Tech.Zone, right? We are focusing on metaverse and 5G. It's a full day conference. Feel free to look this up. And this is going to be an in-person, but we have not decided to actually do a what do you call virtual. But if there is a virtual, I will definitely send information about this for you guys to join and learn more about how Web3, metaverse, and 5G all come together for different use cases, right? So I'll keep you guys posted on this. Stay tuned to receive more communications around this particular activity, and then we will go from there. So thank you, guys. Thank you once again, everyone. You all have a wonderful evening wherever you are. If you have not completed the survey, make sure you complete the survey. We will send you the presentations out to those who have completed the survey. Thanks, everyone. Take care. Bye-bye. Unless you have anything to tell me.
Thank you. Thanks, Kader. Have a nice day.
Thank you, Kader. Thanks for putting up these sessions. It was really useful.
Thank you, Parthiban. Right? Don't forget to fill the survey. Take care, guys. Bye-bye.
Thank you. Thank you, Kader. Thank you.
Thank you all.
Thank you all.
Thanks, Kader. Great session.
Thank you, Kader. Thank you all.
Bye-bye.